Let's talk about the law of sine and when we can use it. So let's say what the law of sines states. The law of sines actually could be stated in words kind of conveniently. So the law of sine states that the ratio of the sine of an angle to the side opposite that angle is constant in any triangle. That's not how we have, that's not the working version of the law of sines. That's just how we would say it in words. So this is how we would write the law of sines in a way that we can use it to solve problems. We would say that the sine of an angle, the ratio of the sine of an angle to the side opposite that angle is constant. So we'll say sine alpha over A equals sine beta over B equals sine gamma over C. So we'll take three equations and just combine them into one super equation. We can also have, it's the ratio is constant, and if I flip over all the ratios, that's the same thing. So we could also write this as A over sine alpha is equal to B over sine beta is equal to C over sine gamma. It all depends on how comfortable we are flipping around our ratios and solving equations for denominators. So if you're using this law of sines to find a side, you can use the blue version and pre-flip everything over. So the structure of the law of sines makes it pretty clear when we use the law of sines. We use the law of sines when we have an opposing pair. If I have A and alpha, law of sines is going to be the way to go. If I have B and beta, law of sines. If I have C and gamma, we can use the law of sines. We can't use the law of sines, for example, in the law of cosines case. If all we have is side A, side B, and side C, I don't have the law of enough information for the law of sines. I don't have an opposing pair. I've got the bottom of the three terms, but I've got no way to equate those things. So this completes our discussion of use the law of cosines if you have to. Let's talk about how we could use the law of sines to solve for a side or an angle. So I'm just going to use alpha and beta here. If I have sine of alpha over A is equal to sine of beta over B. I could use this to solve for A, or I could use this to solve for alpha. Or I could use, so if I'm going to use it to solve for alpha, I want to multiply both sides by A. So I'd say sine of alpha is equal to A times the sine of beta over B. Here's what it would look like in single line syntax. And then to get alpha itself, we would do the sine inverse of all this stuff. So we would type alpha is equal to sine inverse of A sine beta, close parentheses, divided by B, close parentheses. If I wanted to use this to solve for a side, if I start with A on top here, if I have this A over sine alpha is equal to B over sine beta. If we multiply both sides by sine of alpha, then we'll get A is equal to B times the sine of alpha over the sine of beta. Or in single line syntax, we'll have B times the sine of alpha, close parentheses, divided by the sine of beta. Once we have two parts of an opposing pair, A and alpha, we could use that to solve for one of the other parts. One thing I do want to point out, I want to grab this part right here. Sine alpha equals A sine beta over B. Notice that A is opposite side, side A is opposite angle alpha. Side B is opposite angle beta. If beta is a 90-degree angle, then B is the hypotenuse. And this statement reduces to sine of alpha is opposite over hypotenuse. So if beta is equal to 90 degrees, then B is the hypotenuse. And the sine of 90 is equal to 1. So this statement becomes sine of alpha is opposite over hypotenuse, because the sine of beta will become 1 if beta is a 90-degree angle. So the law of sines is kind of like your generic sine of opposite over hypotenuse. Just like your law of cosines is your generic Pythagorean theorem. So we're going to use the law of sines when we have an opposing pair. Any questions? We will do some more examples of the law of sines when we come back on Tuesday. There is a danger case in the law of sines, but we'll talk about that in more detail on Tuesday. That's going to be it for today. I will see you all on Tuesday. Everybody have a good weekend, and thanks for playing.